Hi there. In this video, we'll be looking at a interesting property of logarithms where you can actually change it so that the base and what is being acted on switched, although it is rewritten as 1 over the entire thing, or to the negative 1 power. On that note, you are going to need to know several things. What a logarithm is, of course, which is when you're trying to find the variable up here, which is if the variable is an exponent. There we are. And to do that, what the variable is acting on, this b in this case, becomes your base here. So log base b is, that's how it is said, of a, which is the answer of the original here, equals that variable. You are going to need a calculator or start guessing what x is to get from b to a. You're also going to need to know this exponent property. If it is to the negative 1 power, then it becomes 1 over that. It does hold for other negative powers, so a to the negative, I don't know, we'll just say b, equals 1 over a to the b power. So it does stay as 1 over a to the 1 there. And you're also going to need to know the power rule for logarithms, which is gone over in another video. And there should be a link in the description to that other video, as well as a link to my main logarithm video where I go more into basics of logarithms. Anyway, the power rule is that if it's log base b and then it's a to a power, you can rewrite it as that power is being multiplied by the whole thing instead, and it goes away here. So it's a nice way of getting rid of exponents if they're in there, which is how we're going to use it here. So we're going to start, as we often do in these videos, with b to the x power equals a. Usually we do this so we're taking the logarithm base b of a to x. But what if we do it the other way? So this is a to the 1 power, which, again, it's something you should know. Any number can be rewritten as itself to the first power. Anyway, in this case, we will get, all rated here, log base a of b to the x, because it's the whole thing it's equal to. B to the x, I can write, equals 1, because that's what we're solving for. Now, with the power rule, this becomes x, much better, times log base a of b equals 1. Now let's get everything rearranged as we might otherwise. So that is log base a of b equals 1 over x. Or, again, using what's below, we can rewrite this as x to the negative 1. Although we might want to keep it as this, so I'll just get rid of that real quick. There we go. And the equal sign. I got rid of too much. There we go. So, we usually don't like having x in the bottom of a denominator, and if we can help it, and we can definitely help it if we multiply both sides by x. So, x, and I'm sorry if you heard that. My phone went off. Multiply both sides by x, and then divide both sides by log base a of b. So that would be the same as multiplying by the fraction of 1 over log base a of b. Log base a of b. 1 over. Yeah, that looks fine. That looks fine. Anyway, that simplifies to x equals 1 over log of base a of b. And we do know, so if we did this normally, this would of course be log base b of a equals x. Because we are going to need to do that. We can rewrite this as log base a log base a of b to to the -1 power. And x, we know from that quick little deal up there, no equals log base b of a. So this shows, through all this, it shows that all of these things are equal, which gives us the property up here. So it can be useful, maybe not the most useful property, but it is neat to see that you can switch these around essentially, and it would still be valid. You just got to make it 1 over it. Like I mentioned before, there are videos in the description to the other log properties, and I may eventually make exponent properties to show stuff like this. And if that ever does happen, those will also be in the description. Hopefully this was interesting, and really hopefully it was helpful, but I won't hold my breath for that. Maybe it helps you see some different logic to be able to solve other problems. But yeah, I will see you in the next video.